Good day, everyone. I've come once again today to teach you. Today, we want to discuss mathematics, and the topic we want to discuss is indices. So, follow me. Let me show you how to solve any problem that involves indices. Let's go. All right, we have the topic indices. Indices is the plural form of index. It is the plural form of index. And index, in the other hand, means power. Index simply means what? Power. So when you have something like this, x raised to power 3, so it means that index of x is what? Is 3. That is what? The power of x. All right, when you have something like this, 9 raised to power 4, it means that the index of 9 is what? Is 4. So when you have more than one index, we refer to it as what? Indices. So when you see indices, it means problem that involves alphabets or numbers that have what? Powers. Is it clear? All right, so the indices, we derived it from where? From power. All right, so while solving problems that involve power, that is indices, we have some laws that are governing them. Those laws, we call them laws of indices. So it is advisable that you know the laws of indices so that it will enable you to be solving problems that involve what? Indices. Follow me. Let me show you the laws of indices and how they can be applied. All right, we have laws of indices. All right, the first one we have is what we call multiplication law. We have multiplication law like this. Multiplication law. All right, so this one is applicable when you have something like this. We have x raised to power 2 times x raised to power 3 times x raised to power maybe 5 like this. As you can see, we have multiplication like this. That means this is multiplying this, and this is multiplying this, and this has index, this has index, and this has index. This multiplication law says that since that the same x bears this power, the same x bears this one, the same x bears this one, but it cannot be applicable when what you have here is different from what you have here, or different from what you have here. Before this multiplication law will be applicable, what you have here must be equal to what you have here, must be equal to what you have here. Since you have x having power here, x having power here, x having power here, this law now says that since it is x that we are talking about, that you are going to bring out what? 1x. The power you have here should be written here. This multiplication should be what? Plus. Then the power you have here should be written here. This multiplication will be plus, and the power you have here will be this one. Can you see that? All right, so we have 2 plus 3 will give us 5, plus 5 you have 10. That means that this will give us this. Can you see it? So that is what multiplication law of indices says. All right, another one we have is division. We have division law like this. Division law. This division law states that when you have the same alphabet or the same number bearing this, maybe they are dividing like this. Can you see that? When you look at this now, you have y here and you have also y here. When you have y here and x here, it cannot be what? Be applied. If you have 5 here and you have 7 here, it cannot be applied. For this thing to be applied, you must have 5 here, 5 here, 7 here, 7 here, y here, x here, x here, and so on and so forth, just the way we have here now. All right, so this will give us, since we have y here and we have y here, we'll pick y. This power we have like this. Division goes with minus, that is subtraction. Then you write the power of the second power here, that is second y here. Can you see it? All right, so you have y, you say 7 minus 3, it will give us 4. So you have like this. Can you see it? So this simply means that when you have multiplication, you do addition. When you have division, you do subtraction. All right, next one we have is number 3. We have the zero law. Zero law. Okay, this one states that anything that has power anything that has power of 0, that is equal to what? 1. For example, when you have x raised to power 0, this law says that it is equivalent to what? 1. When you have 20 raised to power 0, it is equivalent to 1. Likewise, when you have 5 raised to power 0, it is equivalent to 1. All right, and so on and so forth. So anything raised to power 0 is equal to what? Is equals to 1. That is what this one is talking about. All right, next one we have is negative. We have negative law like this. Negative power. Negative power law, or you may call it just negative law. All right, so when you have something like this, for example, I have y raised to power minus 2. Can you see it? If you have y raised to power minus 2 here, as you can see, the power is what? Is negative. Can you see it? The power is negative. So what do you do? All right, so for you to remove this negative, you do 1 over what we have here. That means this will give you something like this. Can you see that? This will give you something like this. So this minus has been taken care of by writing 1 over what we have here. Is it clear? So this power will now be here. It will now be power of this. So minus has been what? Removed. When you open this, you are going to have this, that it should give you 1 over, I have like this. Can you see it? So that is how negative law can be what? Applied. I don't have much space here. Let me clean this and continue over here. All right, next one we have is this, I call it fraction law. What I call them may not be what your textbook may call them, but I call them the names that will enable you to understand it. So it doesn't matter. There's never a time they will ask you what is the name of this law in your question. That's in your examination. They can only say something and say you should solve it. I'm calling the names that will enable you to understand it as simply as possible. So follow me. All right, we have fraction law. All right, for example, when you have something like this, assume you have this, and you have this. Can you see it? So it means that the power is what? Fraction. The power is fraction. This simply means that this power will be what? Root. It will be what? Root. So you have like this. This will be inside the root. So if you have 1 over 3, that means 3 should be here. That means it's cube root. If you have 1 over 2, 2 should be here, square root. If you have 1 over 4, 4 should be here, fourth root. If you have 1 over 5, 5 should be here, fifth root, sixth root, seventh root, and so on and so forth. All right, assuming that we have something like this, let me say this one, you have raised to power 1 over 2. This simply means this 9 will be here and you have 2 here. You know, this means what? Square root. You can also choose not to write it, but you know 2 is here. What is the square root of 9? Square root of 9 is what? This. Can you see that? Assuming that you have also this, will you have this? Something like this. You notice that you have 8 like this. The power is 1 over 3, so 3 should be here. This thing means what? Cube root. Cube root of 8. Of course, cube root of 8 means what can multiply itself by itself in order to give you 8. And that means what? It is 2. Can you see that? So that is how it can be solved. Sometimes this fraction can also be negative. Let me show you what you are going to do, assuming that this fraction power is negative. Let me show you. It is not difficult. What if you have something like this? Maybe you have minus, you have 1 over 3 like this. Can you see that? As you can see, the power here is fraction, but it's negative fraction. What do we do? First of all, you take care of what? This minus by saying, like I said, minus means 1 over. You have 1 over like this. Can you see that? So this will now be raised to power this. Can you see that? Is it clear? All right, so That is it. So this is a cube root. You now say that you put this in root like this. So this being 1 over 3, that means 3 should be here. Can you see that? That is how this can be solved. It is not difficult. All right. Having shown you all these laws and more, I want us to solve some examples now so that you see how this can be what applied. All right. So that leads us to example 1. We have example 1 like this. All right. We have something like this. The question says evaluate this. So we have solution like this. So when you look at this, it's talking about what? Multiplication. According to multiplication law of what? Indices, you should go with what? Addition. Since this is x, x, x. So let me bring down the whole stuff here. I have like this. I have this raised to power minus 4. I have this raised to power 3. Right, so I'll pick x like this. What do I have here? I have 7. Then I have plus. What do I have here? I have minus 4. Then I have plus. What do I have here? I have this. Can you see that? So this 7, look at it here. Multiplication is plus. This minus 4, look at it. Multiplication is plus. And look at 3, look at it here. So we have this. You have 7. Minus times plus will give us minus. You have like this. You have plus. You have this. Can you see that? So you say 7 minus 4 will give us 3. Plus 3, it will give us 6. So you have this. Can you see that? That is how it can be solved. All right, let us solve example 2.